We are starting now the questions from the kinematic of topic of this M1 syllabus, which is concerned with the derivatives and the integration. The question is, a particle P of mass m is acted on the by the resultant force F, which is a constant in the direction, and it has a magnitude equal to k into 1 minus small t over capital T, where t lies from 0 to t, where k and t are constants, and where t is the time. If particle p is at rest at that time, t is equal to 0, then find the speed of the particle p at any time, the distance moved by the particle p during this interval from 0 to t, the power divided by the force F at any time t, and the value of the t when the power is maximum. So this is the question which is having the four parts. Now we will stop one by one question from this part. So we know that for this particle, you are going to calculate the velocity, which is the integration of acceleration dt. So from equation of this F is equal to ma, this means A is equal to F over N. So F is basically equal to K into 1 minus small t over capital T whole divided by M there. So this will be equal to K over M 1 minus small t over capital T. That is the value of this acceleration there. And we are going to now integrate this part for the velocity. So that is equal to k dt. So k is a constant, m is a constant which is taken outside, and then 1 minus small t over capital T into dt. This is equal to velocity, which is equal to k over m as is one integral is t minus t square over 2t plus constant of integration a, because they have not given the limits there. But we know that when it is started at this point, when v is equal to 0, t is equal to 0, and the displacement is also equal to 0. So we put this condition into this one, then v is equal to 0, a over n, t minus t square over 2t. So time is 0 there, this is 0 there, plus constant a. So this is 0 minus 0, 0 into this 0. So a value is equal to 0 there. So our final velocity is equal to a over n into t minus t square over 2t within the interval of that from 0 to t seconds here. So this is the velocity of this equation there. Then the second part of this one is find the displacement. We know that the displacement x is basically the integral of velocity. And velocity is given to you as x, it is from the limits from t is equal to 0 to t there. So we can write this thing as 0 to capital T k over n into t square minus t square over 2t dt. So this will become x is equal to k over n as this. T integral is t square over 2 minus t cube over 2 3 is 6t plus another constant of integration d there. Because we are putting the limits from 0 to t, so we can write this thing as 0 to t is the limits there. So it will now become equal to k over n capital T square over 2 minus capital T cube over 60 minus if you put 0, 0 square is 0, 0 square is 0, so this will be 0 here. So the displacement x is equal to k over n t square over 2 minus this is t cube and this is t, so it should be equal to cancel by this t, so it should be equal to minus t square over 6. So this will be equal to k over n, 6 is the LCM. So 3t square minus t square, this will be equal to k over n, 2t square over 6. So this will be equal to k over 3n into t square. This is the displacement of that equation in terms of t here. Now the third part, C, they are asking find the power. Since power is equal to force into velocity, and we got these two equations from this part, that the force is equal to k times 1 minus small t over capital T into the velocity v is given by equal to k over m into t minus t square over 2t. So this will be equal to k square over m into 1 minus small t over capital T into t minus t square over 2t. So power is equal to k square over n into, you just multiply this. So t minus t square over 2t minus t square over t minus minus plus, it should be equal to t cube over 2t square. So this will be equal to k square over n into t minus, if you take common here, t square over 2t plus t square over t plus t cubed over 2t square. So this will be equal to k square over n into t minus 2t is the LCM of these two. It should be equal to t square plus 2t square plus t cube over 2t square. So this will become equal to k square over n into t minus 3t square over 2t plus t cube over t 2t square. So this is the value of this power there. Now, the last part of this last part D, find the maximum power at the time t here. So you know that for the maximum power, we put dp by dt is equal to 0. And we get the value of t from this equation. So P is equal to k square over n into t minus 3t square over 2t plus t cube over 2t square. So we find dp by dt for this. So k square over f is a constant there as it is. T derivative is 1 minus 6t over 2t plus 3t square over 2t square because k and t are constants and that thing should be equal to 0. So k square is constant, so it should be equal to 1 minus 3t over t plus 3t square over 2t square that is equal to 0. We will take 2t square as common as LCM. So it should be equal to 2t square minus 3 into 2t into t plus 3t square whole divided by 2t square and that thing is equal to 0. So finally it will be left there 2t square minus 6t into t plus 3t square equal to 0. This can be written as 3t square minus 6t into t plus 2t square equal to 0. But it is a standard quadratic equation in terms of the variable t there. So we can apply this quadratic formula directly to that. So t is equal to minus b plus minus b square minus 4ac over 2a, where a is equal to 3, b is equal to minus 60, and c is equal to 2t square. So this will become time is equal to 60 plus minus square root of 6t square is 36t square minus 4 into 3 into 2t square 4 divided by 2 into 3. So that thing is equal to 6t plus minus 36t square minus 4 3s are 12, 2s are 24, t square square root divided by 6. This will be equal to 60 plus minus 36 minus 12, that is 12. 12t is equal to 4 into 3. So 2 root 3t divided by 6. It should be equal to t is equal to capital T plus minus root 3 over 3 into capital T. But since the values of the small t is from 0 to t, so it means we have to avoid this plus sign here because it is more than t value there. So it should be equal to t minus root 3 over 3 into t. We take t common, it should be equal to 1 minus root 3 over 3. So this is the time where its power will be maximum value to that equation there. So this is known as we call the total solution of these four problems for this kinematic topic regarding first we have taken the velocity, then we have taken the displacement, then they have talked about the power, and then they are asking about the rate of power. That means the change of power dp by dt, that thing is equal to 0, and then we got the value of t there.